is not just an upgrade, it's a fundamental shift in how humanoid robots learn. Helix VLA enables a robot to perceive the world, interpret commands through language, and immediately translate them into motion, just like humans see, understand, and act. Crucially, Helix VLA isn't bound to a single robot. It shares experience across the entire fleet of figure robots. This kind of collective memory is what makes Helix so unique. If a robot in California learns to organize items in a cluttered kitchen, that same skill is instantly shared with a robot in Tokyo. This type of networked learning wasn't possible at this scale before, and it could dramatically speed up how humanoids adapt to real-world chaos. What we're seeing is the emergence of robotic intuition, built from millions of micro-lessons that never fade and only sharpen over time. The future of AI may be collective. As the mind becomes smarter, the body becomes more sensitive. Sanctuary AI recently unveiled new tactile sensors for their Phoenix robots. These sensors give robots a sense of touch nearly as sensitive as humans, detecting forces as small as 5 millinewton. Now Phoenix can detect and react to slipping objects in real time, by adjusting its grip, allowing it to handle delicate items like eggs or lab tools. Meta is moving in the same direction, but with a different approach. They're training embodied AI using multimodal data, visual, audio, and tactile, so robots can anticipate rather than just react. Their hand prototypes can manipulate soft fabrics and irregular objects with eerie precision. For the first time, robots are not just grasping. They're now understanding texture, force, and friction. Touch could be the next big thing for them. Speaking of breakthroughs, AI has now designed a working microchip. Researchers used reinforcement learning to allow the system to develop a functional design in real silicon. The result? A functional chip comparable to expert-designed hardware, but created entirely by an algorithm. This opens the door to faster prototyping, lower costs, and AI-designed AI hardware. Now let's go back to real-world testing. Gemini Robotics from Google DeepMind has been putting AI into chaotic conditions. In one scenario, a robot was asked to place the grapes into the transparent container. When the containers were switched mid-task, the robot doesn't freeze. It paused, re-evaluated, and still completed the task correctly. This demonstrates high-level spatial awareness and contextual reasoning.
Pick up the basketball and slam dunk it.
AI is changing the game in medicine. A new model achieved nearly 100% accuracy in diagnosing various cancer types. Other systems can detect Parkinson's or dementia more than 15 years before symptoms appear. Prevention is no longer guesswork, it's predictive and data-driven. But there's still a lot of work to do. A new AGI benchmark was released this week, and most of the leading models failed. The test was designed to assess abstract reasoning, logic, and knowledge synthesis, and it revealed how far we still are from achieving true general intelligence. GPT-4, Claude, and Gemini all struggled with consistency and planning in complex scenarios. The message is clear, we've come far, but AGI is still out of reach. The results? Disappointing. Reasoning-capable models like OpenAI's 01 Pro and DeepSeek's R1 score between 1% and 1.3% on the ARC AGI-2 benchmark. Powerful but non-reasoning models including GPT 4.5, Claude 3.7, Sonnet, and Gemini 2.0 Flash scored around 1%. The test covered everything from abstract logic to real-world problem-solving, areas where AGI is supposed to shine. But these numbers make it clear, even the most advanced models today are still far from true general intelligence. So whether it's collective robot brains, human-level touch, AI-designed hardware, or medical breakthroughs, one thing is clear: we're building something great, but we're also hitting new limits. The future is coming really fast.